and welcome back to day 2 of the 6G Symposium. Once again, my name's Alex Lawrence. I know you were probably expecting to see Rahim Tafazoli here, acting as the moderator for this next session. I'm afraid he couldn't be here. He's had some surgery, so Rahim, we hope you are recovering well, and we'll look forward to seeing you at the next one. But in the meantime, you'll have to make do with me, so my apologies for that. Having said that, once again at 6G Symposium, we've got what I hope are going to be some fairly controversial topics to cover, and I'm really looking forward to getting your input as well as we go through this. Now, what we're looking at today is, particularly in this session, is the standards process and how that might be improved. So I've taken the liberty of having a couple of slides for this, just as by way of an introduction. So if you wouldn't mind bringing those up on screen, thanks. So essentially, where are we now? I think we're quite early on. Oh, is this not moving? The slide clicker thing needs to be plugged in. That is an important detail. So this is the anatomy of what this standards process looks like. Just for context, I had a look back over the 5G timeline, and it actually surprised me by how quickly this moved. So you can see along the bottom, we've got some of the standardization process activities, and then along the top, some of the commercial elements. Now, I was stunned actually by the revisiting how closely tied some of the very early deployments were to what was released through the standards. There has been feedback that I've heard that the process was maybe rushed in order to sort of satisfy the opportunity to race to be the first to deploy 5G. Whether that's a question of national pride or other things. That's purely rumor. I'm sure that as we're talking through today, we're going to find some other things that maybe didn't quite work in the standardization process before, things that maybe we need to address in this next time around. Because, for context, we are still pretty early on. That's where we'd be on, if this were the 6G timeline. Last November, the ITU released their vision for IMT 2030. We'll be going into 3GPP later this year. So there's a whole lot to play for. And I guess one of the questions will be, fundamentally, how do we make sure that when we're doing the standardization process, we're making it suitable for what the outcome is likely to be and what the operators and their customers are going to need at that time. So that's essentially my contribution to the debate here, just kind of to set the scene. What I would like to do next is invite up each of our panelists. They've got a presentation, so I'll invite them up on stage one by one to just share their ideas quite quickly. And then after that, we'll bring them all up on stage together for a panel conversation. And again, we've got people ready to hand over microphones to you in the audience as well, in case of any questions. So without more ado, I'd like to invite up David Bosworthick from ETSI.
Alex, thank you very much.
Thank you.
Clicker. Good morning, everybody. Welcome to the brave people who come in for the first session. My name is David Bosworthick. I work for ETSI. I'll do the traditional energizer. Who in the room knows ETSI? Put your hand up. Well, everybody's awake. Perfect. Okay. So for the small minority who don't know ETSI, ETSI is a standards body. We're based in Europe, in the south of France. We are a European standards organization. So we make standards for Europe, European law and regulation. And we also make standards which are used internationally. We're a founding member of 1M2M, which is a global project working on M2M IoT, and we're also a founding member of 3GPP. And this is where the conversation gets relevant. We're back in the beginning of GSM, 3GPP, so we've been involved in that process for 25 plus years. My job in ETSI, so I have a strange title, Director Net, New Emerging Technologies, is basically to do what is on the slide behind. Very fresh slide. I wrote it at 7 o'clock this morning because I couldn't sleep. So this is what in ETSI we're trying to do. We're trying to link research standards and industry. Basically, that's it. So there are a number of European funded projects. So SNSJU, you may have had a presentation on that yesterday. Phase 1, Phase 2, Phase 3. Many millions of euros being pumped into European universities and research projects. And what we're trying to do is ensure that all of that direction and investment is not lost. Research is wonderful, but if it just finishes in a white paper which isn't used, it's less wonderful. So what we're trying to offer is that ETSI works with multiple research projects, be they the European. So we're already working with SNS Phase 1 projects, or regional, so we're working with UK projects. So in the UK, there are projects called Reason, YORAN, and Tudor, funded by FONRC and UK TIN. So there's money coming into the UK government as well, which is being used to fund research in the UK. In a similar manner, I guess there's people from all regions here. There is a 6G initiative in Germany, in France, in Portugal, in Spain. So what we're trying to do is offer a place where these research projects, when their research is mature enough, they can bring that into pre-standardization, full standardization, and then on to market. Very simple. So now I need to remember what I wrote. So, of course, you can't standardize without knowing where industry's going. So a lot of our job is watching technology trends, market trends, and knowing exactly where the industry is going. If you can't predict the next big thing, you can't standardize it when the time is right. To this end, we have a thing called a technology radar, ETSI's ETR, ETSI Technology Radar, where we're basically looking at what's coming out of the European Commission, what's coming out of the UK government, where they're sort of saying we need to do more there, do less here. Okay, that's one element. Look at what our 920 member companies are doing. So this company is buying this company, this organization is partnering with this organization. They're investing in chips, they're investing in Li-Fi. So really knowing where our members are going. And then out of that, we can identify technology trends and tendencies. From that, we can say maybe in 3 years' time, 5 years' time, we're going to need a standard for OWC, optical wireless. We're going to need a standard for free space optics. And from that sort of foresight, we can predict where our members may wish to go. At the same time, we consider SRIAs, which are the strategic research innovation agendas, I probably got that wrong, which are driving research projects. Well, with all of that, we can see where is the industry going from a technology point of view, and also from maybe a business point of view. When the time is right, we tend to work with these research projects and say, okay, you're working in similar areas, RIS, terahertz, ISAC, which we'll come back to later. These projects are working there. Would you like to come together and share your thoughts in pre-standardization? So to this end, we set up these little groups where we can get members of those projects to come together and say, okay, your research is interesting. Let's do some pre-standardization work to scope it, share use cases, share architectures to make sure that when it is time to bring into full standardization, be it in ETSI, 3GPP, IEEE, IETF, ITU, that the standards are ready to be accelerated through those standards bodies. So over here, we can, let's do this. Over here, we can see it's very important that we actually work with the researchers in their labs and say, okay, you're doing great research, but have you considered standardization as a way of getting value for that research? You've had a great invention, a great idea. Have you thought about IPRs, patents, SEPs? That's a very useful way. Have you thought about building the community? That's another useful way of making value on that great research. We work with the projects. So in many of the SNS projects, I'll be supporting them via an external advisory board, just telling them how and where to interact with standards. Working with also informing them about the purpose of standards. I mean, many researchers, they just care about research. It's great, it's beautiful, it's elegant, but you know, if you have research and it doesn't go anywhere, it's elegant but not used. So it's how standards can enable the researchers to get value out of their research. Then when the time is right, it's making the right standard. So this is Etsy's been in existence for 35 years or so, and standards have evolved, and they are evolving a lot, particularly today. We've got traditional standards, we've got open source standards, we've got 3GPP, we've got ORAN, we've got TM Forum. Things are shifting very quickly, and throw into that AI, beyond the technology, it's actually changing the way that standards need to be written, and standards are written. Imagine 10 years ago, the standards we had are not the same as they are today. We're using much more electronic tools to interactively draft the standards. But in 10 years' time, standards for AI and standards with AI will be a completely different ballgame. So back onto this sort of radar, we need to know where industry is going and where standards bodies is going as well. So make sure that we make, so this is a simple mantra, we make the right standards. So standardize just enough, not too much. So don't standardize options, standardize high level frameworks that will actually enable industry to compete on a sort of compete on a differentiation of the options. Standardize at the right time. If you standardize too early, it will kill the market. If you standardize too late, it's irrelevant. So standardize at the right moment when industry needs that standards to enable the technology to be built to hit the market at the right time. Market at the right time. And then, as I said earlier, to the right level of detail. Don't standardize a massively rigid system if it's not needed. It may be needed in some circumstances for security and other such things, but standardize just enough. And then make sure that they're clear, well-written, and relevant. Maybe this wasn't remembered back in the day. Write a spec which people can understand. Some of our specs have been commented recently on LinkedIn, and that was great. That was fresh. So we're getting this whole new community looking at our specs from a sort of a market critical perspective, as opposed to the people who are writing the specs. So this sort of feedback loop from the market is really important. So make sure the specs are well written, clear, and understandable. Over to this bit, where are we? Number 3. Once the standards are written at the right time, in the right way, in the right language, make sure they're used. As with research, you don't want to have research sat there not being looked at. Also standards, you don't want to have standards sat there not being used. So if you've written pre-standardization, make sure that it is taken up by the relevant standardization group. So Etsy's ISGs need to focus on getting the work into 3GPP, into whatever group. It's pointless having the specs made and not used. And also make sure that they sit well in the ecosystem of standards bodies. There are lots of standards bodies working on similar areas, particularly as you move up the sort of triangle, as you move up to security and AI and policy. There's many standards bodies working in that area. So you need to be clear about what is the purpose of the standard you're writing. And then make sure that when you've written this, well, when our members have written the standard, that they actually use it. We've had many standards groups where only 20% of the standards are implemented in products. So the ideal is that industry comes together, writes the standard, and then uses it in the product to ensure global outreach, interoperability, and such things. So this is sort of my 7 o'clock thought on the nature of things. I hope that's clarified. You're now going to hear about one of our ISGs, which is on a topical beyond 5G, 6G topic, which is sensing, ISAC or JSAC, as you prefer. And this is an example of writing standards at the right time to the right level of detail, pre-standards, which will then hopefully be used by 3GPP and then be taken up by market. So with that introduction, I will hand over. Thank you very much.
Thanks very much, David. And I'd take a seat in the audience if I were you. It'll allow you to see the other presentations. Having said that, I'm also going to take a seat in the audience and welcome up Alain Morad from Interdigital and also the head of Etsy's ISAC, ISG. Alain, over to you.
Okay, so good morning, everyone. My name is Alain Morad. I'm with Interdigital, responsible of the 6G standard research in Europe. and I'm standing here in my capacity as a chair of the ETSI Industry Specification Group on ISAC. ISAC is standing for Integrated Sensing and Communication. So David made my job much easy to kind of, tell you more about how we went about getting this ISAC ISG between research to standards, which is the scope of my talk. Some animation. David, all right. So basically, just to reiterate actually what David said, so we picked, this topic from the research activity in Europe, but also globally on integrated sensing and communication. We picked it early on as a topic to consider, mature through the framework available to us at ETSI for pre-standardization. So that was about like 2 years ago. And then we came with a proposal to ETSI to streamline all this research that's happening in Europe, but also globally on ISAC, and have it in a shape that is ready to be taken up by standard groups like 3GPP. And that was actually ahead of 3GPP signaling an explicit interest into the topic, in the package, in the 6G package anyway, for 3GPP. So for those of you who follow a bit the 3GPP, there was a workshop in Taiwan, June 2019. At that workshop, companies shared their reviews on Release 19, which is understood to be the stepping stone for the 5G studies. And it was quite interesting, actually, at that workshop that multiple companies from all over the world brought the topic of ISAC, which was actually happening in tandem with our initiative to bring this topic based on the research that was happening in Europe, but also globally, to ETSI to streamline that research into standards. And then here we go, when we kicked off this ISG back in November last year. So 3GPP was also trying to set the scope for the Release 19. And we can say, now that we know what's in the scope of Release 19, we can say with a fair amount of certainty that ISAC is going to be actually a topic taken by 3GPP into its studies for 6G going forward. Now, ISAC as a topic is really rich. We may call it actually a bit disruptive in a way. A bit like the other topics that David mentioned, like RIS and terahertz, but we can say again with fair certainty that ISAC is going to actually make it into the 6G package of 3GPP. So that's just to kind of tie up, the topic to what David presented earlier. So I'm going to be quick actually into presenting this ISAC ISG. So what's the mission for this ISG, as I outlined a little bit earlier? So it's pretty much to streamline actually the efforts, the research efforts happening in Europe, but also internationally, streamline them, mature them, put them in a proper framework available to us at ETSI through these ISG, and be ready actually to support, a specification of the technology in bodies or groups like the 3GPP. And to make it also crystal clear, our job is not duplicate the effort of 3GPP. Quite the opposite, is to be complementary with 3GPP and then ensure that what we do is relevant to 3GPP at the right point of time. So that's why our focus is pretty much actually into the Release 20 plus, try to influence and complement and support the effort at 3GPP, but not exclusively 3GPP. I mean, as we also appreciate, there is some interest into the topic also to return back to Wi-Fi standards going forward. So that's also in our radar as well. So, so pretty much the mission of the group is to establish a technical foundation of this technology, ISAC, which is, in short, ISAC is about actually using or reusing the radio waves of the cellular system, in this case, in the case of 3GPP, to do sensing. So as opposed to doing sensing using a different technology or a different spectrum or a different hardware. So here the idea is using your radio signal, cellular radio signal, you may be able actually to also, enable some radar capability into the signal. So we've got 5 main topics in the scope of the ISG. Topic number 1 is around road mapping, the use cases, ensuring that we know which use case, what level of advancements does that use case require, and we put it right in that roadmap, short term, mid-term, long term, so that we know actually when to address it at what point of time and with what enabling technology from ISAC. The second is quite important, is what we call the development of the advanced channel models and measurement frameworks. Obviously, up until now, all these channel models are communication-centric with a transmitter and a receiver and nothing in between that's considered meaningful. Now with sensing, since we are sensing target objects that may or may not be connected to the network, we add a new degree of freedom. That new degree of freedom that becomes meaningful, then obviously we need to account for this in the modeling. And there are different ways of doing that modeling: stochastic, deterministic, data-driven. So all these options, we are looking into these options in our scope of the ISG. We also importantly try to develop evaluation methodologies, proof of concepts, gaining data to validate the models that we are developing. And then also importantly, we do studies on the framework, the architectural framework, and the deployment end-to-end. So core network, radio access network, and so on. And also very importantly, we have in the scope a study of the impact of ISAC on security, privacy, but also importantly, sustainability, in particular the energy efficiency side of it, the energy footprint of that technology. So that's hopefully a 360 view of the topic. I'm not sure how well am I doing with time, Alex. So I think I'm going to be very quick actually upon presenting the rest of the scope. So these are the work items that have been approved. This is the timeline of the execution of the ISG for the first phase. So the first phase is running for 2 years. We've already gotten 3 meetings with significant number of attendance. We've got more than 83 companies and universities very well engaged into the group. And of course, it's a call for all of you present in the room, but also present online to, if you are interested in the topic, to join us and then start, feeding contribution into this work. Great. So I think I'm gonna skip the rest of these slides, but you appreciate, we've got everything, all the mechanics are in place on all 4 work items, contributions happening with the aim for us to pretty much get a first deliverable, which is the use cases from ISAC ISG towards the end of this year, right on time before the 3GPP run workshop on 6G in March 2025. So hopefully that gives a good perspective on the group. Thank you.
Brilliant. Thanks, Alain. That's very much appreciated. So that's given us a fairly good context from the 3GPP perspective. But I'd like to invite up to the stage now somebody with a very different set of eyes on this. Jean Chouret from Orange. Thanks.
Thank you, Alex.
Floor's all yours. Thanks.
Thank you. Okay, it works. Perfect. So, hi, nice to be there. I'm Jean Chouret from Orange. I'm a senior expert of future networks. And I'm here to talk about 6G value and use cases and how it can be addressed. If we consider value, if we consider how useful service can be, it leads to the question of use case. In Orange, we have considered a few use cases. You might already know it, it's quite classical. We consider that there is value to enabling more efficient human communication. There is value to enabling more efficient communication between machines, to better coordinate them, to allow them to better collaborate between them and with humans. There is a clear link also with digital twin because it will help to better manage resources and be sure that everything's have a better awareness of what's going on, and there is connection to ELs. It's pretty known. This is let's say wide-scale use case that need to be analyzed for technical feasibility. What does it take to support it? How complex it is? What are the costs? But also for market relevance and for sustainability. What does it cost? How many value does it bring? How useful is it to the end user? And more globally to the global society. What does it cost in terms of money, of course, but also in terms of environmental impact, power consumption, impact on the whole society. And to be nicely understood, those use cases need to be co-designed with future user, because if we, as telco engineer, we decide how robots need to operate in a factory, for example, we might have it not as good as someone actually working in a factory. So involving future user is clearly important to be sure that we support a use case in the most efficient way without over-engineering, without being too expensive, without having the right fit, in fact. If we look at a wider scale on the NGMN side, we also have same concept about enhanced human communication, enhanced machine communication, but they also identified a few technical enablers that will unlock new services, for example, sensing, or for example, support of artificial intelligence in the networks. There is also a new set of family, which is network evolution. Here, the idea is to make the operator's life easier, which is a good point. By, for example, supporting an easier digital inclusion, network automation, or improving widely energy efficiency. It's also some very important point that might not be a first focus of the final user, but for the one operating the network, it is extremely important. So that leaves us with two main concerns. First, how to support more capacity in a sustainable way, how to support traffic growth with a minimum cost and while meeting energy and environmental constraints. This is the first point, and there is value with just that. And then how to support new use cases that will by themselves enable value and sustainability benefits. For example, immersive experience, digital twin, and the operational efficiency on the whole system. Understanding those use cases is very important. Involving future user into those use cases to better understand them is really important. And with that, it links us with key indicators of performances, of requirements. And this is where we need to be very concentrated. We know how to address performance requirements. We have a capacity, data rate, connection density, latency, reliability. We are able to set number on that and define KPIs. That's the way, that is how we have done until now for the previous generation. Here, we need to do that, but we need to take into account the enabled value and the practical sustainability. Yes, we can do higher data rate. Yes, we can do better capacity. What does it cost? What will be the impact? What will it bring as a benefits? And we need to face that with societal requirements here. Here, we do need to consider also what will be the energy efficiency of the global system, what will be the global environmental impact, what will be the security or resilience benefit, how many value, how many benefit does it bring, not only to the end user, but to the global system. And for that, we also need key indicator and we need tools to evaluate those key indicators. This is where the key value indicator framework enter into game as a way to how to say that, to balance between the benefits of performances and the benefits of value versus the cost. So, and this will be my last slide, it leads us to the question of how we address value. Some key objective, we have seen that, like energy efficiency, availability, but there is many other one, cannot always be easily translated into technical requirements, into numbers that we know how to address that. So we need a new dimension, and we need to take this new dimension into account when we assess 6G value. This is where the KVI approach, so the key value indicator approach, can bring a framework that will help to quantify the value. We have some experience, like for example with the ITUT 4080, that help to quantify the enablement effect relating to CO2 carbon dioxide impact. We see that having a common understanding, like a common KVI and the assessment methodology, is clearly helpful to bring consensus on how these things will be beneficial or not. We also know that we need to continue exploring how such indicators need to be defined and the methodology to assess them in the future. So there is work to do to help this framework to address more and more topics and take into account those new dimensions. And then it needs also to impact the way we define standards, so the way value is taken into account into standard. Knowing that if we have consensus on the value generated by given 6G use case, it will clearly help to better understand the benefit of these use cases and balance that with the associated requirement. And the more challenging, the more extreme are the requirements, the more meaningful it is to be able to do this balance. So the question will be, how could the standardization organization specify the required KVI as well as they have done for KPI and the evaluation methodologies that go with it? Thank you.
Thanks very much, Jean. I think there were a few elements there which I think were very striking and which I'll look forward to coming back to. But you may well have heard him yesterday. Now you're going to be able to hear more of him. Let me hand over to Sudhir Dixit.
Okay,
from
thank you.
IEEE.
Thank you, Alex. Good morning, everybody. So I'm the last speaker and for this session. That helps me because a lot has already been said. But I'll give the IEEE's perspective or point of view about what they do in general and also what they are doing specifically when it comes to future network standards like 5G and beyond. Because 5G is not only about cellular, it's network of networks. That basically means all the other technologies like Wi-Fi and Bluetooth and all the other good things that go with the 5G and beyond. So I just wanted to, I have a couple of slides to just motivate this need for standardization, which is quite obvious, that we have the technology roadmap. There are many different technologies that go through the concept phase, idea phase, then pre-competitive phase, and then post-competitive phase from an R&D perspective, and then go to standardization and also deployment. So technology standards, and then standards are needed to be able to have interoperability, to be able to scale at the global and national level, and then go to the market. I think what we are all researchers and technologists, but the thing to keep in mind always is that technologies alone does not mean success, but that's a good way forward. With the technology, you have a very high IP content, but the IP relevance may be low from the market perspective. So whenever a new technology is there, there's a need to understand what the customer needs are, what the customer's pain points are, and looking it outside in. And then market opportunity is exploited by utility cost, barrier to entry, and things like that. So it is standards and building to standards a must, but to be successful, but it is not easily done. But open standards is the new way forward. We all know that. So this is a three-legged stool. Some of you may have already seen this, that to be successful in the market at a scalable level, we need technology, we need standards, and we need the market need. So technology and standards, they all need to come at the right time, at the right place in the market. And from IEEE perspective, there are a lot of ideas that come to IEEE standards activities, standards association, and which I'll touch upon a little bit more later. So there are two main steps involved. One of them is called rapid reaction standardization activities. That's a phase, and whereby anybody can submit ideas in a particular domain of interest within IEEE. And there is a RRSA organized in that field, in that domain of activities. And all of those proposals, they are vetted, they are brainstormed, and some of them are selected to go to the project authorization request. And I'll talk about that a little later. Just to give you the scale of IEEE, it has over 400,000 members around the world, 39 societies in a very different field of electronics, not only about radio, about networking, but many other things like energy and so on and so forth. And so all the ideas from these societies come to IEEE Standards Association, where they get screened and they are taken forward. So this is the organizational structure of IEEE from the standards perspective. There is a standards association, and there is a standards association board of governors, and there are many different entities in the standards association, like administrative committee, audit committee, new standards committee, and the patent committee, and so on and so forth. And things like project authorization requests that are evaluated by new standards committee. They are the ones who will review. And just to give you an example, I'm part of the CTU connecting the unconnected working group in IEEE Future Networks Technical Community. Over 3 years, there were about 53 proposals that were submitted for the standardization by IEEE. And out of those 53, 17 were progressed to PAR stage, project authorization request mode, and only 7 were taken further for standardization. And a lot of the activities in IEEE, they are volunteer driven, whereby the individuals and the companies, they both participate. This is another slide, another representation of the same thing. So I'll skip this in the interest of time. Just to give you an example, standards and global collaboration for 5G and beyond is organized something like this, that we have open mobile edge computing, Wi-Fi, soft RAN, augmented reality, IoT, and there are different codes assigned to the work that gets done in each one of those parts of the Standards Association. Okay, so this is the process that is followed when we talk about rapid reaction standardization activities. So I was giving an example, about 53 of them were submitted, and the same thing happens when we talk about Wi-Fi. Wi-Fi is probably the best known standard that has come out from IEEE, and it's still evolving in 82.11ax and BC, BE, and so on and so forth. So basically, an identified standard item goes to RRSA session, and it is evaluated by the committee members. If it is ready, then it goes to the study group. It goes to the project authorization phase. And if there are certain question marks, then it goes to a study group, and then it goes to the PAR phase. If it is not ready, then it goes back to the research project, and research is continued on. So this is typically the process IEEE follows, which is very technology driven. One needs to keep in mind that it's not only about looking at end-to-end architecture and the framework, but it's also looking at smaller modules, depending upon which society the idea or the proposal is coming from. So, okay, so where is the next one? Skipping on me. Okay, so here is a timeline of some of the 5G and future networks related IEEE standards activities. So if you look at how long wireless LAN activity has been going on, it has been going on since before 2000, to right now is continuing in the form of to 802.11ax and BE and so on and so forth, which is called also, the trade name is Wi-Fi 6, Wi-Fi 7 standard that is still in the development, but there are products out there already. And then we have aerial network, which is high altitude platforms, which are in the sky. Those that kind of work is also going on. So when we talk about 5G and beyond, from the networking perspective, the standards are in the space in the area of SDN, network function virtualization, green energy, mobility, and so on and so forth. So there are a number of activities going on IEEE when it comes to 5G and beyond. And they strongly liaise with other global standards bodies such as ETSI, 3GPP, ITU, etc. So they just don't sit in vacuum, and they also work with IETF as well. Let's not forget about them. So right now, just to give you an idea, there are about close to 1,200 active standards that are in use, and about 600 standards that are in the development phase in IEEE. There is a separate working group in IEEE Future Network Technical Community, which used to be called Future Network Initiative up until last year. And there is a working group called Standards Working Group, Standards Blocks. And all the proposals or the ideas, they come to the Standards Working Group, and they vet them, they discuss them, and they put them through the RRSA process. And the ones that are found to be of interest and of relevance, they go to the PAR process, and a formal standardization process gets started after that. So with that, I'll just stop here. Thank you very much.
Thanks very much,
Okay,
Sudhir.
thank you.
Can I ask you to take a seat? And I'll also invite up our other speakers as well. I think this has given us a really good introduction to some of the key concepts and ideas here. But I'd really like to dig into a lot more of this now and try and work out where this is going and how this might change over time in order to give us the standards we need for the next generation. So please do take your seats here. Now, as mentioned, I'd love to get your thoughts on this and your questions. Clearly, though, there were quite a few elements here which have come out already, and I'd love to start off by just asking, you've mentioned, I think, all of you in one way or another, the variety of stakeholders that you include. But one of the things that makes me wonder is to what extent it's possible in an environment like this, where it's highly technical and requires quite a high level of understanding, how much you can get useful input or feedback from potential end users, and is there a way to engage, for example, other industries or potentially consumers in the development of standards that are going to have value to them, to kind of Jean's point, and make sure that then that's actually adding value to the industry. Are there ways that we should be looking to build on the existing process? So David, I'll start with you on that. That's okay.
Yeah, so users, end users, other domains. So this is an important element. From a standards perspective, we rely on our members who draft the standards to understand the user needs. From an operator point of view, see Orange, Deutsche Telekom, BT, they have vertical business customers, they have end users, and we hope that they understand what they need. We in Etsy have user groups, which is our very small groups that have human factor groups, which look at accessibility, safety concerns, about technology in a general, so that all of that's covered. But really, we do need to rely on groups such as NGMN, operator groups who are working with end users, working with vertical users, business users, to be able to understand and predict the future needs. In 3GPP, we have MRPs, market representative partners, who come from the automotive space, agriculture, industrial, whatever, manufacturing, and they represent, this is a quite recent evolution in 5G. We actually consider the requirements of the automotive industry, of the industrial factory industry in the creation of 5G specs to make sure that the 5G that they will use is custom to their needs. This is being increased in 6G as well, because as we predict, 6G will be used a lot more for connecting people, things, and industries all over the world, all over the planet, and in space. So you need to have this conversation up front in the service definement, the user requirement definition, that you actually include all of these people, which is why on the slide I put in inclusive as well, inclusive and relevant.
Yeah, thanks. And Jean, can I get you to comment on that?
Yeah, thank you. It's a very complex question. As you said, we have, for example, for some vertical, some structuration. For example, in the automotive industry, you have 5G ACAA that bring a vision from the automotive ecosystem, and it's clearly highly beneficial. But we do not have that for every verticals, for every ecosystem. Some of them are able to project themselves far away. We are talking about post-2030 networks that will last at least up to 2040, we hope, maybe more than that. So it's challenging for if I go see a customer and say and ask him, hey, what do you think you will need between 2030 and 2040? Usually you don't know. So not all of the customers are able to answer such a question. It's a discussion that we need to have with some key verticals to help them and to work together with them to build this common understanding. This can be done. It's an effort, but we clearly need to dive into it if we want to be really able to understand the value of our future usage and the impact it can have on the whole ecosystems, not only in terms of money, but of global sustainability, economical, environmental, and societal sustainability. The other point is that one of the vertical we have, which is not really vertical, is the global society, because yeah, automotive industry are able to structure themselves, but our average smartphone user has no such representative. So how the society by themselves will rely on communication, on telecommunications, on telco networks post-2030, it's another kind of dialogue that need to be established with this global society. And this will require also some specific tools. It's started already in some project. I'm thinking to ExaX2 research project, for example, where there is a huge societal impact task, but it's the beginning of the journey, and it's clearly an open question on how to connect with the society as a whole, and not only with just a few key verticals that are seen as with right reason as a key markets.
Yeah, thanks. And I wonder, just picking up on this slightly, Surya, you were mentioning IEEE has got all kinds of different areas in it, you know, beyond telecoms. To what extent does that enable you to, you know, cross-pollinate ideas from one industry to another when you're considering the standardization process? To what extent are works, for example, within the future networks area, driven by requirements, let's say in in the energy sector and by IEEE members there. Or is there much of a conversation across the industries, or does it tend to be fairly segregated?
I think it's a combination of all of the above. A lot of the user requirements, if I may expand the scope to consumers and also to the businesses, all of those come from the use cases. And the use cases typically get defined by not only by the users, but also by the entrepreneurs and the application developers who identify the business opportunity, and then they'll take the technology that is available to make it happen. So that's what happens. So industry verticals, they play a big role, and there's always this continuous push to innovate, to provide better experience to the end user. And that's what brings the technology to play a big role. Just to give an example, what has happened in the automobile industry, if you look at the indoor entertainment in the automobile, it has brought many technologies together, right from connectivity to the user interface and audio, video, and all the other things. And but underneath all of those things are standards that make it scalable and profitable for the chip manufacturers and for the equipment manufacturers to make it. Otherwise, things will be very expensive. So from the IEEE standard, IEEE point of view, since they're very technology driven, they don't really, you would hardly find much discussion happening from the business perspective or the business model. It's very technology driven. So there is a need to have this technology roadmap that helps to define the standard. But even the technology roadmap is not very helpful unless we have a framework or a reference diagram. I mean, we saw many reference diagram for 5G, we saw for network function virtualization, SDN, and so on and so forth. So unless you have a reference diagram, it's very difficult to put all those technology components together and have a consistent taxonomy of the technical terms that people will use in the R&D community and also in the industry. So we need taxonomy, consistent taxonomy. Then we need a framework, and when the framework is there, then we need some kind of a reference diagram, and that's when the standards process actually happens to put all these pieces together. Both at the hardest part is the systems level.
Right.
End-to-end systems is the hardest thing to do, but at the component level, it is probably easy to do.
No.
Maybe I can add a little bit on.
Yeah, thanks, Alan. Please do comment. I was going to come back to you, but
Yeah, just actually on the topic of cross-pollination, right, and segregation. One observation I would like to make is that a significant number of stakeholders, they play in both, in these IEEE standard bodies, in the 3GPPs, in the ITUs, in the ETSIs. So naturally, there is a cross-pollination happening within these organizations, right? Even if this doesn't, go publicly in this way, inside these organizations, there is a significant degree of cross-pollination happening.
yeah, thanks, Alan. Now, that actually brings me on to a slightly related question, and that is, well, let's come to that a little bit later, because I don't want David to beat me up yet. So before that, I'm going to turn to you because we're looking at the ISAC, ISG, and I find that a really exciting topic area, simply because we're looking at something where there are commercial products on the market already in some ways. So you're kind of building from a foundation there which already exists rather than trying to create something out of nothing. And so I'd love to sort of understand from your perspective how you take something that's kind of there already and what that means for building it into these 6G standards. You know, are you looking at building on existing successes or building out into different areas, or what's the thought process there on that sort of commercial element?
Yeah, that's quite a interesting question, Alex. So I wouldn't say actually, you know, we've already got, if you like, commercial solutions or even standardization specifications ready, you know, to embrace, you know, ISAC. But there are components and pieces here and there, right? For example, if you take, you know, sensing as a topic, not integrated sensing and comm, just sensing. I mean, obviously we have plenty of sensors all, you know, deployed and used commercially. You got LiDARs, you got radars, you got cameras, you got IMUs, and, you know, the collection of that data, the fusion of that data, the actioning of that data. So this is a technology that's available today. If you take, for example, sensing and Wi-Fi, right? We know Wi-Fi, the standard called IEEE 802.11bf, WLAN sensing, not long ago, it was like 2 or 3 years ago. But basically what they did, they said, okay, with my Wi-Fi specs today, if I were to enable some limited use cases of sensing, so what is it that I can achieve? But they did not look into actually, how can I actually optimally, right, consider that sensing as a native capability into the design of the system, which they are going to be actually, my understanding, looking at in the next few years, right? But there are pieces in there, like we tested out through the existing system, the Wi-Fi system, the WLAN system, we tested out, you know, whether or not we can actually enable certain use cases. So this is available today, right? And now, if I go a little bit more to the typically conservative kind of, you know, body like a 3GPP as we know it, right? So what 3GPP did recently that is seen as the cornerstone or the stepping stone, if you like, for bringing ISAC is what we call the positioning framework, right? Obviously with 5G, multiple use cases put a requirement on accurate positioning, right? Down to the sub-meter level, or even some 20, 30 centimeter levels, especially for smart factories. So this is what actually triggered 3GPP to bring, you know, new specifications, new signal design, right, to enable that positioning requirements. And that was proven to work. And based on that, you know, component, they said, now we feel ready to go to the next step, right, which is bring sensing, right? Pretty much like positioning. But then it's all actually into that keyword of integrated I, sensing and comm. So how integrated you would like to be. That level of integration actually will dictate, you know, how radical the disruption is going to be on the, you know, the signal design, the protocol design, what you can afford as use cases. And that's why we believe actually all these pieces, all these components, whether from Wi-Fi, whether from the sensor fusion, whether it is actually from the positioning framework, all these things, you know, are going to be used and then put in a roadmap that is going to be actually executed upon, you know, in steps. And that's why we believe actually that roadmap is going to be actually spanning at least 2, 3 releases in 3GPP going forward. And hence, you know, the HCI ISAC to say, look, we know first phase is going to be this. We are positioned to bring advances that are going to be ready for that next phase when it comes to, for example, 3GPP and IEEE as well.
Fantastic, thanks. Now, I will go to the audience shortly, but something else that you mentioned there sort of highlights one key issue for me. I mean, I think we're quite lucky being here together, this group of us, in the sense that we've got people here who very much understand the industry, understand how it works. And as you mentioned, there are people that will work across a variety of different industry groups and standardization bodies. My concern is that means that we've got a relatively small number of people who are involved in this, and very much like with politicians, it's quite a small group of people to be able to influence with, you know, cognitive capture and get them all thinking in the same directions. I had a conversation with somebody last year who will remain nameless, who was commenting that with the whole 5G, you know, concepts of remote driving and so on, it was something that got people very excited, and you know, nobody felt comfortable speaking up against that and just going, "Look, hang on, that's not really very feasible." And so we ended up sort of pushing through some things which, you know, have not come to market in the ways that we would have expected. And I'm just curious as to whether there are opportunities within ETSI, within 3GPP, NGMN, IEEE, to police against that kind of cognitive capture and build in different perspectives, or, you know, or if there isn't, should there be? I'll throw that one over to David.
Why, oh, why? Yeah, it's a vast question. Good question. Yeah, how to ensure that 6G is a more open, more successful than possibly we had for 5G, maybe a sub-question in that area. We in standards, as I said, listen to our members listen to their customers, be those other operators, other vendors, other service providers. So we hope they understand where the industry is going. I think with 5G, and I'm not sure if this is being recorded, but with 5G, maybe the promise was bigger than delivery, and timescales didn't meet exactly what people hoped for. We're not driving around in autonomous cars everywhere today. We're not being remotely having remote surgery everywhere today. Nobody's being shaved on top of a mountain in the UK somewhere today. So they're good for promoting a vision, but possibly they do confuse expectation. So I think possibly being realistic with expectation is intelligent. Actually providing something which meets a business need at the right moment is also the way to go. So technology will evolve, researchers will research, standardizers will standardize. I've heard this recently, and things will move forward. But we don't want to make a beautiful technology which is useless in a context. We don't want to make technology for technology's sake, sorry, and we don't want to standardize a technology so rigidly that it cannot evolve. We've heard again that NGMN operators have said that 6G must be a soft and elegant evolution of 5G, an addition of useful features at the right time to serve the use cases. So I think all of this is saying let's not slow down, because people do want to accelerate, but let's at least consider what the technology will be used for in which market at which moment. So again, use cases, ETSI will stop there, 3GPP will stop there, but then business cases, business models, ecosystem models, what is the role of the MNO, MVNO, private networks? These are things that ETSI does not consider. We don't look at business, but we look at the technologies to support business. So somebody needs to be thinking about this technology of sensing is fantastic. How are we going to use it to make, ETSI is not allowed to say the word money, but to make good business. NTN is interesting. It will give you great coverage and connect the unconnected and bring in sustainability factors, but how is anybody going to make business out of it? You have great proprietary standards such as the various LEO constellations which are being thrown up there. They work very well. There's a business model developing, but when you try to standardize those sort of end-to-end solutions, what will that do to the market? So again, from a technology and standards point of view, we will do the technology standard, but somebody needs to be keeping an eye on the roadmap for technology deployment in a business scenario. And I don't know if that profound answer answered your profound question, Alex. I hope it did.
It's certainly helpful, but I will turn Jean to and this is something which the NGMN is in a position to do, for example, because it seems as though if you listen to certainly a lot of the major sort of national scale and international telcos, they've got some quite different models for how they plan to evolve and what they might look like over the next few years. So I wonder whether again you are facing this sort of challenge in terms of either having too many different ideas about where to direct your efforts, or if there is there being consensus, maybe too much. I mean, how do you balance that?
Yeah, well, that's a good point. That's a good question. I would say that 5G has set a cornerstone because it was the first time it clearly passed the idea in the global audience that cellular networks, mobile networks are not just for smartphones, but have an interest for a much wider audience, from low-cost IoT sensor to connected cars or machine, factory plant, and so on. So it's really something 5G has achieved. It has spread the idea that no, mobile networks are not just here for smartphone, but can do much more. And maybe at a slower pace than what we were hoping for, it get interest from other users than smartphone users. So something has started for real. It's true that in the automotive industry, but in other industry as well, people are looking more and more with more and more interest to what is happening in the telco industry, and it drives the idea that they need to get interest. And if you look in 3GPP attendance, we have not just operators and equipment provider. We also have a representative for this market, from this market, or even companies that are not really involved in in smartphones or in network vendors. So it seems to me, maybe I'm optimistic, but it seems to me it is started. No, it means that those people have interest, they do they show it by coming, by attending. So we need to be able to listen to them. We need to hand them the microphone sometime and check what they have to do. And I'm really not sure we can have too many input from too many users. But you're right. It will be part of the challenge will be to be able to get everything and to do some sorting at a given time, because we cannot also future networks will have to sort at a given time between what was to be addressed because there is value in there, and what's maybe for a later time because market's not ready, because technology is not ready. Also, it can happen, and that's what SDOs, in fact, are also made for. We have it's true in IEEE, but we have a different criteria to start a new, to give a positive outcome to a project authorization request. If I'm correct, there is a 5 criteria that need to be met, and in those criteria, there is technological maturity, but there is also market interest. If I'm correct, tell me if it's not the case. In 3GPP, there is also the question of, okay, this study item is interesting. How many times will it how many effort will it require, what will be the final benefit, and it seems that SDOs are more or less already have a tool to do that. I will be rather confident in this point, but we just need to continue encouraging people that are out of the telecom market to get interest into this scene and contribute to it.
Can I?
Yep.
Yep, by all means to do.
So, very good question, Alex. I think one of the challenges that we face in our telecom networking community is our perception to the industry verticals. Somehow, the industry verticals feel that whenever you talk about 5G, 6G, or computer networking, this is meant for the networking people. So they don't come to our events, unfortunately. Even here, we don't see any representation from the industry verticals such as automobile, manufacturing, education, or whatever. And what we have realized in IEEE, at least in the past 1 year, that how do we get the industry engaged? So I'm part of the industry engagement committee. I'm a co-chair there. And what we have agreed to do is that we'll go to their events rather than inviting them to our events. So for example, if there is an automobile event, we'll reach out to them and say, well, can we get a half-day session to have a workshop on 5G and beyond, and tell you a little bit about some of the use cases that are relevant and how can the networking can differentiate your products, what it can do for you. So we need to do that, change this perception, go to their activities, and be more visible. And I must say that the IT industry and the software industry has done a great job, fantastic job. Whether you go to manufacturing or you go to automobile or banking, finance, the IT industry is there because they need IT services. So the software industry is in bed with them right from the beginning. But the telecom, computer networking, we come at the end or just to connect things. Whether it is an airline, airline industry can make a big use of so many communication technologies that we have in baggage tracking, checking in, and so on and so forth. But we are not there. So the point I want to make is we need to go to their event, find out what their workflows are, and how can communication technology improve the performance of their workflows, and how can it bring down the cost. Those are the two things they listen. We can show, if we say, go and tell them that, look, you completely replace your workflow in a manufacturing, they're not going to do it because they have revenue coming. But we can go and say, well, if you automate this process by using this communication technology, whatever it is, piece by piece, they will jump on it. But rarely do we do that. And so the point is, software and IT industry has done a great job, but we come toward the end. We go there just to connect things up.
Yep.
But we should be providing more value that the connectivity provides, which we hasn't done. So so there are silos when it comes to the industry verticals.
Excellent, thanks. Yeah, David.
Just to build on that, one example, last week we did a big NTN 6G event in Etsy, where we managed to attract the satellite communities, which is quite unusual. We cooperated with GSOA, ESA, European Commission, SNS, and others, and we had probably half the people in the room were from the satellite community. Obviously, it's a domain, it's a vertical, it's an enabler for 6G, it's many things. So that's one way we can go to their events, they can come to us. If we look beyond 5G and 6G, in Etsy, we have probably about 10 to 15% of our members are non-ICT core. We have car manufacturers, we have aeroplane manufacturers, we have people working in the space industry, we have people working in the health industry who are members of ETSI and who contribute to specific technical groups in ETSI. In a similar way, in 3GPP, there are members who are not traditional ICT companies. You would look at the list of names, you say, ah, that's interesting. So already the WISE industries are getting involved in the standards activities where they will be using connectivity in the future. And that's how they directly influence. Often in the higher levels, so requirements, directions, use cases, but also in the sort of the security, accessibility, reliability areas as well. So this integration has definitely begun in 5G. I think it's very true that 5G was the first G generation that was really designed for business and beyond just simple devices. And it will accelerate to 6G because we'll be connecting more things and more people in more industries. So it's happening. It needs to accelerate, but we mustn't beat ourselves up. It is going quite well. We just need to do more.
Just one thing to react also. What is the important point we need to understand too is timing, because some verticals are able to move fast because they are used to that, because their business allows them to do that. Some others don't, because especially, for example, the ones that manage huge infrastructure, they build stuff that are here to last not 10 or 20 years like our pace, but half a century sometimes. So we also need to be able to adapt to the rhythm of those different verticals. Some are able to move fast. Okay, let's embed them. Some need more time. We need to show them that we have a long time thinking and even commitment sometimes about how we understand their needs and how we can collaborate together. So this timing question is important, and the way to answer that also is the flexibility we are thinking you were mentioning earlier. Yes, we need to show that what we are doing now will not be dumped in 10 years, but that we will be able to elaborate on what we have built to continue supporting and even support new use cases at a later time. So it's clear that the flexibility, the evolutivity of our system is important. And with this next generation, we have an opportunity to show that from what we have laid as a foundation with 5G, we're able to build on it and to show this evolution path to show that it's real. And in the same sense as showing it's real, we are an industry as well, so we can also use for our own needs this new capability. For example, people are more and more thinking about digital twin for the networks. So we are going to add twinning our network for better managing it. At the beginning, digital twin was really something from the aeronautic industry. What we are developing to better support verticals, we also need to, we can also show that we're able to use that to better support our own needs and be an example by ourselves. Thank you.
Brilliant, thanks. Now, I'm being told that we're going to have to wrap up shortly. Time has absolutely flown, but I keep saying I'm going to turn to the audience for some questions. I'm absolutely going to do that now. So if anybody would like to speak to these people, then yeah, see Peter there.
Okay, so the 6G network has the ambition to become more and more programmable. What do you see is the role for open source as standardization by design?
I think that's probably initially a David question.
I'll begin the answer. Yeah, open source is a definite contender for defining standards of the future. In ETSI, we do traditional standards, which are basically documents with lots of lines, diagrams, and formulae. And also we do software development groups, which are basically living code, often implementing models which have been defined in the traditional standard. You need a very quick loop between the open source code, which is evolving quickly, and the more traditional standards framework, which is evolving slightly slower. We've seen recently developments of open source in the area of 5G, O-RAN. This needs to be done in a sort of harmonized way with 3GPP. We don't want to see those two going in different directions. But it is important to consider, as I said earlier, the standards we made 10 years ago are not the same as the standards we make today, and they won't be the same as the standards we'll need to make in 10 years' time. So always keep an eye on what is needed. I'll say it again with AI. So we're talking about the network for customers, but also the network will evolve using AI. The network will need to support AI, and a lot of that will need to be done with agile evolutions and therefore software developed code. So yes, it's happening. It needs to happen more, but we need to make sure that open source doesn't devolve from or break away from traditional standards. They need to go in a very quick feedback loop and evolve together.
Thanks. And time for one more. We'll give that to Dean.
So David.
Hi there. How do we avoid standardization driving unnecessary levels of lock-in? Obviously, standards do lock in certain things, but how do we reduce dependency between groups of standards, for example, between the RAN and the core? Yeah, today you can drive Wi-Fi from a 3GPP core, but you can't drive a 3GPP radio from a Wi-Fi controller. So how do we decouple? Do all interfaces have to become APIs, for example?
That's a fun question. I'm going to potentially point that to Surya as well as to David, and sort of see what we get.
I think it's a very good question. The dilemma that is there is this balancing act. If you have standards that by nature of the standards, it limits what you can do. But at the same time, at the same time you lose the flexibility. However, if the overall, the systems level, if we take the example of Open RAN or softwareized RAN, or whatever we call it, if it is a modularized property, whereby it is modularized properly and there are standards for each individual models, and they are interconnected through standard interfaces, then the standard of those modules can continue independent of the other modules for a longer period of time. So I think the end of the day, it all boils down to how much forethought has gone on breaking that architecture into smaller entities and making sure that the information flows in all the directions wherever it needs to with openness, so that there may be cases where it is perhaps not always possible to know what would be needed in the future. But the question is very, very, very interesting one and very important. I don't have a particular answer to give to you as to what is the way forward, but I think that's the best we can do.
Okay, a quick comment from David, perhaps.
Yeah, thanks, Dean, for an intriguing question. I think it's been clarified that 5G evolution 6G will involve multiple radio air interfaces. So you will have 5G radio, 6G radio, Wi-Fi, Li-Fi, satellite. All of those will be merged together into something, a network, which we will call the future network or a sixth generation of connectivity networks. They will all need to work side by side, be optimized for the connectivity that is required in that place, in that business sense. In Barcelona, there was one demonstration from a UK university. I think it was Bristol, and they were showing Wi-Fi, Li-Fi, and 5G networks side by side, doing 3D modeling on objects and then reconstituting. That maybe is the way to go. Multiple radio interfaces, moving over a single system, so orchestration between those radio interfaces, working side by side on a need basis. So if you need this network, you use this network. If you need that network, you need that network. Obviously, the networks won't all be available in every location, but it's having this ability. So again, standards can enable interoperability. So having this ability to choose the right network to hand over when the requirements are met. So that, I think, is the way forward. And again, I'm only a standards expert, not a technology expert. That is the way forward for 6G, is having multiple connectivity networks, connecting users to the data they need to provide at any given time. And we'll see how that evolves. But that's definitely what we're seeing with sort of 5G evolved, 6G early proof of concepts. That answers?
Yeah, one thing I want to add here, just
Right.
1 minute,
Just-
is
Just quickly.
what I was going to say, I think you brought up a very good point of interoperability. When we think from an end-to-end perspective, and if your data is flowing through many different operator domains, there needs to be a compatibility between how the parameters are defined, even though you may have APIs, open APIs, and complete flexibility to how you set the parameters and so on and so forth. But even then, there is a requirement, or there is a need to have standard templates. Otherwise, you won't get the desired quality of service end to end. So even though there may be, you can provide a lot of flexibility, but you have to limit that flexibility to a limited number of options through the templates, so that your session or your application can work across operator domains and across the network elements that your application or your session is going to encounter, even though they may be softwareized. So the end-to-end quality of service really puts some conditions. That's the reality. If you really want to be able to scale it, and if you want to make it provide the reliability, and want to be able to measure the performance, and so on and so forth.
Thanks. Now, I'm very much aware that we're up to time, and we're keeping everybody from their morning coffee at this point. Now, so we'll break there. There are a whole heap of areas that we can continue discussing. So I suggest that we do that over the biscuits. But do make sure that you come and join us here at the top of the hour again, when we'll be asking the question of whether chasing sustainable 6G technology is a realistic goal. So I think that's going to be quite a fun, quite a controversial one. So do please join us for that. But in the meantime, please give a big round of applause for the panel here.